Hey everyone, you ever stop and think about what's really going on when you click a link, send an email, or start streaming a movie? It feels like magic, right? Well, today, we're going to pull back that curtain. We're going to build from the ground up a solid understanding of the incredible architecture that connects our entire digital world. And it all starts with one simple question. How on earth does a single click from your laptop travel across continents, maybe bounce off a satellite, hit a server thousands of miles away, and get a response back to you in what feels like an instant? It seriously seems impossible, but it's not magic, it's just a brilliant system of hardware and rules all working together in perfect harmony.
So, here's our game plan for putting this all together. First, we're going to start with the absolute basics. What even is a network? Then we'll look at the physical stuff, the cables and boxes. After that, we'll get into the digital rulebook that everything follows. Then, the fun part. We'll follow a single piece of data on its journey. And finally, we'll see how it all comes together to create the connected world we live in. All right, let's dive into part one. Before we can build this massive structure, we got to have a solid foundation, right? So let's figure out what this fundamental building block, the network, actually is.
You know, at its heart, a network is actually super simple. It's just a bunch of devices. Think your phone, your laptop, maybe a smart TV or a printer that are all connected so they can share stuff. And that's the key word, sharing. That's the whole point. Whether you're sharing a funny video, access to a printer, or just sharing that one internet connection for the whole house, it's all about making a bridge for resources to flow between devices.
Now, of course, networks come in different sizes. Think of a LAN, a local area network, as your own neighborhood. It's small, just your home or your office. And because everything's so close, it's really fast. But a WAN, a wide area network, that's like the entire highway system connecting all those neighborhoods together across the country. It covers huge areas. The internet itself is the ultimate WAN.
And it doesn't stop there. We can get even smaller or bigger. A PAN, a personal area network, is just for you. It's what connects your phone to your Bluetooth headphones. A WLAN, or wireless local area network, well, you know that one is Wi-Fi. It's just your neighborhood network, but without the wires. And then you can go bigger, to a MAN, a metropolitan area network, which can connect a whole city.
Okay, so we get the concept of a network, but what is it actually made of? What can you physically touch? That brings us to the hardware, the actual nuts and bolts that form the foundation of our digital world.
So every network is laid out according to a blueprint, which we call it topology. The one you'll see pretty much everywhere these days is the star, where all your devices connect to one central point, like a Wi-Fi router. It's just super easy to manage. You might hear about older ones like Bus or Ring, but they had a big problem. If one part broke, the whole thing could go down. And then there's the mesh topology. It's incredibly reliable because everything connects to everything else. But as you can imagine, it's also pretty expensive to set up.
Okay, so we've got the map. Now we need the actual roads for the data to drive on. The two main highways are your standard copper Ethernet cable, or UTP, and the amazing fiber optic cable. Fiber sends data as literal pulses of light. The difference is huge. Fiber is insanely fast, can go for miles and miles, and is the real backbone of the internet. Copper is great too, just perfect for shorter distances, like wiring up all the computers in an office.
So we have roads. But roads are useless without intersections and traffic cops to direct everything. A switch is like a local traffic cop. It's only concerned with directing data inside your neighborhood, your LAN. A router, on the other hand, is like a major highway interchange. Its job is to connect your network to all the other networks out there and find the best route for your data to take. And of course, you have your access point, which is just the on-ramp for wireless devices, and the firewall, which acts like a security guard, deciding what traffic gets in and what gets out.
All right, we've poured the concrete and laid down the asphalt. The physical foundation is there. But you can have all the roads in the world, and without traffic laws, you just have chaos. That's where the digital rulebook comes in, making sure every device, no matter who made it, can speak the same language.
That rulebook has a formal name, the OSI model. The easiest way to think about it is like a 7-step postal service. Way up at the top, layer 7, is what you actually see and touch, your web browser, for example. When you send something, your data travels down through the layers. Each layer does one specific job, like putting the data in an envelope, adding an address, putting it in a mailbag, until by the time it gets down to layer 1, it's just raw ones and zeros, electrical signals flying down a cable.
Now that's a lot of layers to remember, I know. But here's a little trick that network engineers have been using for decades to get it right. All people seem to need data processing. It's a mnemonic: application, presentation, session, transport, network, data link, and physical. Just a handy way to keep that complex system straight in your head.
So while that 7-layer OSI model is the perfect blueprint for understanding how it all should work, in practice, the internet you use every day runs on a slightly simpler 4-layer version called TCP/IP. It basically just groups some of those OSI layers together to be more efficient. The core jobs are all still there, from what you see in your app all the way down to the signals on the wire. It's just the real-world, working version of that bigger idea.
Okay, this is where it all clicks into place. We've got the physical roads, and we've got the digital rules of the road. So now let's actually follow a single piece of your data as it goes on this incredible journey from your screen out into the world.
This whole process is called encapsulation, and it's literally like packaging a letter to be mailed. Your actual email text, that's the letter. The transport layer puts it in a nice envelope called a segment. Then the network layer slaps the full destination address on it, and now it's a packet. Then the data link layer puts that packet into a local mailbag called a frame for delivery around the neighborhood. And finally, the physical layer turns that whole package into a stream of ones and zeros to send down the wire.
And this is why that packaging is so important. Remember those traffic cop devices? They use these different layers to do their jobs. A switch, the local cop, only needs to look at the address on the outside of the mailbag, the frame, to know where to deliver it within the local network. But a router, the highway interchange, needs to look a little deeper. It opens the mailbag to look at the address on the envelope, the packet, to figure out which highway it needs to send your data on to get it to a completely different network, maybe halfway around the world.
So let's zoom out for a second and look at the big picture we've just built. All of these different pieces, the physical cables, the smart devices, the complex rules, the neatly packaged data, they all have to work together perfectly every single second.
Because ultimately, this entire incredible architecture is all about optimizing two things that you experience every single day. First, bandwidth. Think of this as how many lanes are on your digital highway. The more lanes, the more cars or data can travel at once. The second is latency. That's just the travel time. How long does it take your data to get where it's going? For everything we do online, from gaming to video calls, the goal is always the same. Get the highest bandwidth and the lowest latency possible. A big, wide-open highway with no traffic jams.
So, if you take anything away from this, let it be this. Our entire connected world stands on a physical foundation of cables and hardware. It's all governed by a very clever, logical rulebook that lets everything talk to each other. All of our data is carefully packaged up before it goes anywhere, and every single one of these pieces, from the biggest fiber optic cable under the ocean to the tiniest rule in the code, has to work together perfectly to give us that seamless connection we now take for granted.
And that kind of leaves us with a pretty cool thought to chew on. These fundamental rules we've talked about, they were designed decades ago for a much smaller internet. So as we start to connect billions, and I mean billions of new devices, everything from our cars to our coffee makers, what new blueprints, what new rules of the road are we going to have to invent to build the network of the future? Something to think about. Thanks for joining me.